Hey guys, Mr. Backerberg here. In this video, we're going to look at the midsegment theorem. So as we're talking about a midsegment, what we're talking about is a segment that connects the midpoints of two sides of a triangle. So as we're taking a look at this triangle, let's call this triangle ABC. Let's say that this point right here, and I'm going to call it M, let's say that M is the midpoint of this segment AB. So this piece is congruent to this piece. And let's say we've got another point over here, and I'm going to call this one N. And let's say N is the midpoint of BC. So this piece is congruent to this piece. So then if we connect M and N together, then that MN segment would be a midsegment. Now every triangle is going to have three midsegments, because if we find the midpoint of AC, so say it's right here, and I'm going to call that point P, and if we connect point P to point N, and point M to point P, then those are also midsegments. Now in this picture, we've got that DE midsegment drawn out for us, and there's going to be a couple properties that we're going to talk about. The first property is that midsegment DE is going to be parallel to its corresponding side CB, so we can put arrows on those to show that those are parallel to each other. The other relationship deals with the size, how long this midsegment is, and the length of this DE midsegment is going to be 1/2 the size of the CB segment. So let's say we knew the length of segment CB was 10. Then because that's 10, DE automatically has to be half of that, so it's 5. Now triangles are very strong and stable shapes, so they get used a lot in engineering. So like as we're looking at this roof truss down in the bottom right hand corner, we've got a bunch of triangles highlighted for us. So in this picture, we know that UV and VW are going to be midsegments. Those are created by finding the midpoints of a couple of segments. And we want to use the fact that we're dealing with some midsegments within this picture to help us find the length of UV and find the length of RS. So let's first look at this UV segment, and I'm highlighting that in red. Now UV corresponds with RT. Now if we're trying to find the length of UV, we talked about the length of midsegments as being half of the length of their corresponding piece. So this UV length is going to be half the length of RT. Well, we can see that RT is 90 inches long, so then UV should be half of that, which is 45 inches. Now if I wanted to look at RS instead, RS is this big segment kind of running down the middle of our picture, and that corresponds to the VW midsegment. Now we know that the length of the midsegment is half the size of the big corresponding segment. So VW is half the length of RS. But in this case, we know VW. We know that's 57, and that's going to be half the length of RS. So what I can do in order to figure out the length of RS is I can multiply both sides of my equation by 2. And when we do that, we're going to figure out that this length is 114 inches for segment RS. Now this picture is a little bit different, but what we've got is a triangle with D, E, and F being the midpoints of the sides. So then those red segments in our picture are all midsegments since they're connecting the midpoints. Now what we're told is that DF is 2x minus 7 and AB is 6x minus 12. And what we're looking at doing in here is finding this x value. So the relationship that we talked about is the length of a midsegment, so we can use that DF as one of our midsegments. The length of that midsegment is 1/2 of the length of its corresponding larger side. So DF matches up with AB. So I can take what I know about each one of these segments and plug it in. I know that DF is 2x minus 7, and we've got 1/2 times. I know that AB is 6x minus 12. Now what I can do in here is with this 1/2 out in front of my parentheses, I can distribute that in. So I haven't changed the left-hand side. That's still 2x minus 7. But on the right-hand side, half of 6 is 3x minus half of 12 is 6. Now what I want to do is get all of my variables on one side and my numbers over to the other side. So I'm going to take this 2x and subtract it over to the right-hand side. So I'll get negative 7 equals x minus 6. Then I'm going to take this 6 and I'm going to add it over to the other side. So I'm going to end up getting an x value of negative 1. That's going to be it for this video. Thanks for watching.